Okay, welcome back. This video will cover how to generate a user coordinate frame for the Yaskawa YRC1000 controllers. I talked about why you might want to employ a user frame in another video here, so I won't go over that, but because that video was really for the FANUC controller, and because there doesn't seem to be another English language video for Yaskawa controllers, I thought I would generate this video. So let's get started. So we have our simulated robot here in MotoSim, our display, and our teach pendant. And if you go to robot on the main menu on the left, there is user coordinate, and you can see we have a whole bunch of user coordinates available. There are 3 with the filled in circles indicating they've been defined already. There is a total of 64 available coordinate systems that I can define personally. 1 to 63, and we're going to use number 6, mostly because that's the one I decided to use. If you go to the right side under name, you can hit select and give your coordinate system a name. So after defining the name, I can come back over to the left side, hit select on the number. It will bring me to this dialog where I am going to define what my 3 required points are. The way Yaskawa does a user coordinate frame is to ask for the origin, something on the x-axis, and then something on the xy plane. And so I can select whichever one I want to use. I'm going to move the robot to where I would like to define my initial point, and I can then hit modify and enter. This will record the joint positions. I can then hit select, go to my XX, which is along my x-axis. And the nice thing about this, and the whole point behind this really, is that I don't have to really have these all on the same plane. And so you can see I'm moving down here on the Z. And for XX, I'm going to modify enter to give us that point. And then the XY keeps or locks the new user frame into a rotation around that axis we just created between the origin and the XX point. And so let's come back here and let's go back over there a little. That maybe up a smidge. That looks good enough. We're going to modify enter there. And so now I have all 3 points taught. You'll notice that the cursor on XX is solid. That means that I was there, and as I move off of it, it'll start blinking. So if I press forward, it will move me back to that previously selected location. I can do that with XX to go back to where that was taught, and I could touch it up if I needed to, whatever. Once I'm happy with my points, I will hit the complete button. It will return me back to this screen, and you'll see this is now filled in. If I change my coordinate system to user and then press shift and press the coordinate button, it will show me a list of the user coordinate frames that have been defined. And I can come down to 6. You'll see a 6 up here on the user coordinate system icon, and then shift and coordinate to get back out of that. And so now as I move the robot, you'll notice the Z and the X and the Y are now moving relative to what my new user frame is. And you can kind of see from this angle, it's not moving the way it normally did when it's in traditional Cartesian coordinate. And so if we go to a top view, we can see X is going in this weird direction because we taught 2 points going that direction. Y is 90 degrees from that, and you can't really see anything from this angle for Z, so we'll go to the front view, and you'll see Z is moving up at an angle and it's going up and down this way instead of straight up and down like it normally would. And then again, because of the perspective, we can't really see how the Y changes, but now it looks a little bit more like it's moving on what used to be the X axis. Cartesian X, Y, Z, and so this video here that you're watching is now
User coordinate
live footage
X.
of one of our carts moving in a user
Coordinate Y.
coordinate system versus running it in a straight traditional robot XYZ
User
coordinate
coordinate
system.
Z. X, Y, and Z.
So the reason we have this, or one of the reasons we have this, is when we are using something called an offset or a shift, we can apply this user frame to that part of the job. And so this job I've created, this is really a separate topic, but I'm going to show you the results of this. And so if we go to the top of that there and we run our job, you'll see that it's moving in this kind of odd direction that was functionally defined by the user frame. And so it's not anything we've seen or used previously in class, but it does give us this ability to have these very specialized coordinate systems and motions to be applied to our system. And as you can see in the other views of the cart, even though we're moving in an arc instead of a straight line, you'll notice that the point at which the robot's going to progressively moves further and further back in the cart. And that is because that is the direction that we've defined in our program. And just to give you a little bit of a preview of that, if we were to go to our variables and our position variable, P000 you'll see has a value of Y equals 825 millimeters. That is because what I've done functionally is added 75 millimeters every time the program loops to give me that Y offset, and it only offsets in the Y direction. So hopefully this has made sense. As always, thanks for watching.